Hi everyone, today we'll be doing question 141 on LeetCode today called linked list cycle 2. Idea is we want to find the start of a cycle. So this is kind of a follow-up to 141 linked list cycle number 1 where we wanted to prove the cycle. Now we want to find the start. So we don't want to modify the linked list, and we want to probably use a different solution than from last time using the hash set. So in this time, I'm going to be using Floyd's hair and tortoise algorithm. And let's use paint to draw it out. So just as a reminder, the hair and tortoise algorithm is basically using 2 pointers. One is going to be a slow and one's going to be a fast. And the idea is if there is a cycle, then at some point the fast and slow will intersect. So let's just use the example that we have. 3, 2, 0, -4, and -4 points back to 2. Cool. So we're going to start our slow and fast at the head. And let's start iterations. So the first iteration, slow will be at 2. Well, fast will jump 2 ahead. So fast will jump to 0. Then the second iteration, slow ends up at 0. Fast ends up at 2. Remember that this is the case because we're not going all the way back to 3. We're going back to 2 from -4. Then third iteration, slow jumps 1 forward to -4. Fast jumps 2 forward to -4. So we know that they intersect at -4, and that's where the start of that's where the intersection of the 2 points are. But that's not where the start of the cycle is. The start of the cycle is at 2. So from here, what we can do is we can start another pointer back at the head and just move the um, intersection as well as the head forward until we find the intersection, and that intersection will denote the start of the cycle. So in this case, we can say that this is where the intersect is, and we'll just call this new pointer head. So in the first iteration of head and intersection, head will be at 2, intersection will be at 2, because they both move one at a time. Because they match, this denotes the start of the cycle. And that just about sums it up. So let's put this into code now. So we'll say while fast and fast on next, just in case if there is no cycle, we always want to keep track of the next element afterwards. So in this case, we're going to move slow 1 up and fast 2 up. So this is kind of reiterated from before, but because we need to check whether this has a next pointer, we need to make sure that fast and next is not null. So we can say then if slow equals fast, we'll just call this intersect equals fast, and declare intersect. Then from here, we can say while head intersect, say if head equals intersect, we just want to return it. Otherwise, we just move both of them 1 forward. And by the end, if there is nothing that intersects at all, just return null. So let's see if this works. Something happened. So let's just take a look at why This crashed. Oh, oops. If we find the intersection, we'll break from the loop. That's my bad. Now it should work just fine. Oh my god, this should say slow down. There we go. Okay, so that works just fine, and this works just fine. Cool. Since we're iterating through the entire list, this is just all done. N is the number of nodes in our list. So with that, I'll put a link to the question as well as my GitHub down below, and I'll see you guys next time.